Now we take the section at a distance x from the fixed end, and once you are drawing a section, at that very section we assume the shear force to be V and the bending moment to be M. Since the load is varying as you move from the fixed end towards the free end, the intensity of the load across the beam is varying, with the maximum intensity being W0 at the free end. The point where you are cutting the section, we assume that the intensity of the load be W as a function of X. Now look at this figure. This is there are two right angular triangles in this figure. You have the larger right angular triangle and this smaller right angular triangle. From the similar triangle concept, we say W0 divided by L is equal to W as a function of X divided by X. So we have W0 divided by L is equal to W of X divided by X. So from this equation we obtain the value of the W of X. W of X is equal to W0 by L into X. So the value of the intensity of the load at the point where we have drawn the section is equal to W0 by L into X. This is how the intensity of the load varies across the span of the beam. Now for this section which we have isolated from the main beam, what we will be doing, we'll be again writing the equations of equilibrium, and the equations of equilibrium will be, we have Ra acting upwards whose magnitude is 1/2 of W0 into L, we have shear force acting downwards, and we have this triangular distributed load acting on a span of X. The value of this triangularly distributed load will be equal to the area under this load diagram, that will be 1/2 of W of X multiplied by X, and this triangular distributed load will be acting at the centroid of this smaller triangle, and the centroid of the right angular triangle from this fixed end is at a distance of 2/3 of the base, that is 2/3 of X. So writing the equations of equilibrium, so we write minus V, because the shear force we are assuming to be acting downwards, Ra is acting upwards, minus 1/2 of base, that is X, multiplied by the perpendicular, that's equal to W of X, but W of X is equal to W0 by L into X, that's W0 by L into X. There's no other force acting on the beam along y-axis, we put it equal to 0. So once we are doing algebraic calculations, we obtain the value of V. The value of V comes out equal to W0 by 2L into L square minus X square. So this equation, that's equation number 3, gives us the variation of the shear force across the span of the beam as with the variation of X. So as the X changes, the shear force varies, and this is the formula that gives us the variation of shear force across the span of the beam.